Hey everyone, it's chapter 17, which means we are comparing groups. And this is page 12. Let's read this example and we're going to be, I've already given it away. The first two examples are on proportions and the second two are on means. So let's read through and try to understand why I might be able to make that decision. So right here it says a survey of 430 randomly selected adults found 21% of the 222 freshmen and 18% of the 208 sophomores had purchased books online. Okay, so guys, here we go. We've been given two completely separate groups. So what they're giving me here is a P1 hat and an N1. And then this is P2 hat and N2. So let's record that information because right here it says we're going to create a confidence interval. And then it says below, is there evidence that freshmen are more likely to purchase make online purchases of books? Use alpha is 0.05, okay? So it says create a 95% confidence interval for the difference between the proportions. All right. So this says, let's see, P1 hat is 0.21 and N1 is 222 freshmen. Freshmen. So this means that we need to figure out what X1 is. So remember that it's going to be N1 times P1 hat, which means it's 222 times 0.21, which gives me here, I don't know why it doesn't like my pen today. We want to round accordingly. This was 46.6 when I put it in the calculator. So we're going to round that. Let me change that to an approximation symbol because we're going to round that to 47. Okay, I'm going to do the same work here for, we're going to find X2 the exact same way, and then we're going to go ahead and run a 2-prop Z interval on these two values, okay? So we'll go ahead and do it right underneath. There's plenty of room, I think. We'll see. Okay, P2 hat 0.18, and 2 is 208. So X2 is going to be N2 times P2 hat, or 208 times 0.18. And we're going to round this guy too. This happens to be 37.4. So we're going to round it accordingly down to 37. We want this to be as close as possible to 18%. And we want X1 to be as close as possible when we put it over 222 to 21%. Okay, so that's why we're making these choices in rounding. Now, we're going to go, finally, right? We have the information we need to go to the 2-prop Z interval. So we're going to put X1 equals 47, N1 equals 222, X2 equals 37, N2 equals 208. And that's, we need to also, include, the confidence level, which we want to put in as a decimal, 0.95. And that's all the information that we need. So out of that, we get an interval. So I'm going to run out of room for interpreting it. So hopefully I can make my handwriting smaller than ever before. 0.0448 is my lower bound that I got. 0.1048 is the upper bound. So I'm going to make an interpretation here. But one thing I can see is that this is negative as a lower bound and positive as an upper bound. So we can pretty much conclude that the two groups are similar because there's a negative lower and positive upper means 0 falls somewhere in that interval. And the two groups are probably too similar in percentage for us to make a conclusion that they're any different. Right now, we're not running the test. We're just going to interpret the interval here, okay? So let's go ahead and say we are 95% confident the difference in proportions of freshmen and sophomores purchasing, it's very specific, I know, I need room, books online falls between, and then I actually want us to practice converting these to percentages, because these are actually how they expect you to answer it on Pearson. So it falls between 4.48% and 10.48%. Whew, okay, that's a long sentence there. So let's continue with part B here. We already did all the work for finding X1 and X2. If you look at my solutions, I repeat the work just so you can see where the numbers come from, but I'm not going to repeat it here with such little room. We're going to go ahead and set up the hypotheses and run this test. This says, is there evidence that freshmen are more likely to make online purchases of books? Write your hypotheses, perform the test, find the test statistic, the p-value, and state your conclusion using alpha as 0.05. Whew, okay, so let's begin with writing hypotheses. I want to remind you that for the 2-prop z-test, which is what this is, let's write that over here, 2-prop z-test. Remember, this is a test on 2 different proportions, which is what we decided from reading it at the very top. The null hypothesis always looks like this. P1 equals P2. And then we're going to try to figure out where the direction comes from. Is there evidence that freshmen are more likely? Awesome. So more likely means that the freshmen would have a higher proportion than the sophomores. And the freshmen are indeed our first group, so we will call them group 1. Okay? They already came first in the sentence, and I call them group 1, and so we believe that they're more likely to, or higher proportion, to purchase books online. All right, so go ahead to your calculator. We're going to do a 2-prop z-test. X1 is 47, N1 is 222, X2 is 37, N2 is 208. This is a test on groups, so we don't need a null, we don't need a hypothesized value. We just give it the direction. And then out of our calculator, we get z equals, and z is pretty small, 0.8842. So it's less than 1 standard deviation away from the mean. And then p-value, and the mean in this case is 0, so these are really close to one another. The p-value is 0.1883, and alpha was 0.05. So the p-value in this case is much larger than alpha. So here we would fail to reject the null. So just to clarify what that means, there is not enough evidence to show freshmen are more likely to purchase books online than sophomores, right? More likely than who? Than sophomores. Okay? We are going to do one more. In the next video, I'm going to follow up with example 2 also on page 12. So go ahead and watch that and let me know if you have any questions at all. This one's just going to be a test, not both an interval and a test.